Sarah King, and I am the Admissions and Program Services Manager at the Data Incubator, and we are a fellowship, scholarship, and placement company. We have promised you an excellent info session, which will be led by one of our instructors, Michael Cullan, and Michael will be linking a notebook in the chat that he'll be using during his presentation. So once it is linked in the chat, please make sure you have access and you can follow along. But to get things started off, I wanted to give you a quick overview of our program and everything that we offer. Then Michael will jump into our live demonstration, and we will leave some time for questions at the end. Please place all of your questions in the Q&A section, and we will answer them at the end of the presentation. As a reminder, our session is an hour long today, so if we don't get to all of your questions today, please email us at admissions@thedataincubator.com, and we will be happy to help you. We will also include that email address in the chat box as well. So moving along. So what the Data Incubator focuses on training people to become data scientists. And why is that important? It's really because data scientists have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a ton of different industries, ranging from tech to finance, healthcare, retail, and many more. Every company has data and wants to use the data to drive value for them. So there are a lot of data science programs out there, and what do we do at the Data Incubator that's a bit different? Well, what we've found is when you look at training, there are really two types, one being fast-paced and efficient, and the second being slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. On-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So we've taken all of these aspects and combined them together to find a great middle ground for training. Fast-paced, you walk out of the program knowing a lot about data science and real-world business applications, and with a deeper understanding that you'd get from university. All of our instructors are PhD and master holders and have completed this program themselves and know how to provide that in-depth training that you are looking for. So a little bit more about our fellowship program. It's not your average program. It's definitely intense. That is that fast-paced schedule I was speaking to earlier. It's 9 to 5, Monday through Friday for 8 full weeks. I will say that is for our full-time program, and we'll go over a little bit more about our new part-time program as well. It's very thorough. Each week focuses on a different data science tool or approach. And in addition to our lectures, we have students participate in hands-on practice. We really believe in fostering an interactive learning environment, and each week you'll be working on a mini project that focuses on that data science tool you are studying. Some of the topics we cover are TensorFlow, machine learning, Spark, data visualization, just to name a few. Additionally, our program is very collaborative. We want students not only to work with their colleagues and instructors, but also work on presenting to companies. Part of our program is working on a capstone project that you'll have the opportunity to present to our hiring partner network. You'll get feedback on how to present, how to create a capstone with a clear business objective, and a great portfolio piece to add when interviewing with companies. Our program is also forward-thinking. We have career coaches that help you with the career aspect of becoming a data scientist, not only learning how to become a data scientist, but actually getting a job in that field. That involves work with your resume, cover letter, interview skills, and negotiation skills. And to help connect our students with our hiring partners, we host virtual networking events. We do partner panels where companies will come in and talk about what it looks like to work at a company and discuss problems they're currently trying to solve. We also host capstone showcases where students have the opportunity to present their capstone projects directly to hiring partners. In addition to this, we are happy to announce our new part-time program. The part-time program lasts for 20 weeks with classes held on Mondays and Thursdays from 7 p.m. to 9:30 p.m. Expect to spend 10 hours per week working outside of class, and office hours are available each week. You will receive the same excellent curriculum and training, but at a slower pace, and the sessions are live and instructor-led, so you're still able to interact with your instructor and ask questions. Here's an overview of our program, our part-time and full-time curriculum broken down week by week. Please email us again at admissions@the-Data Incubator for a more detailed curriculum overview. So we admit 2 types of students into our program. Fellows are offered tuition-free scholarships for our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. They are not required to interview solely with our hiring partner network, and they maintain any current employment. Scholars still have the same access to curriculum, resources, and tools as our fellow students. And so that is just a little bit about our program. I will now pass off to Michael to lead you through our live data science demo, and then I will come back at the end to help answer any questions.
Okay, thank you so much, Sierra. Hello, everybody. As Sierra mentioned, my name is Michael, and I'm one of the instructors here at TDI, based out of New York City. I put this link in the chat earlier. I'm going to paste it one more time because of just the way that Zoom works. And if you logged in after I pasted it, you wouldn't see it initially. So I just put a link in the chat, which will take you to, basically will let you launch today's content on mybinder.org, which gives you an interactive notebook that you can use just in your browser, which is really great. So make sure that I've got the right window showing here. So once you click that link and your server loads up, you'll see a file browser like this. And we will be working out of this first steps demo .ipynb file. So you'll end up seeing this notebook. I'm actually going to switch over to a local copy I'm running just because I've already got the data loaded in. And I'll make sure I'm kind of suitably zoomed in here. So many of you may likely be familiar with this platform and file format. IPython notebooks with Jupyter Notebook Server. If you are not, this is definitely like a pretty ubiquitous tool in data science and like reproducible research. It's something that we use all the time in the fellowship. And it just gives us this nice kind of interactive and editable, we can run and write code kind of format where we can have nice kind of formatted text, figures, images, hyperlinks, in addition to these little chunks of code we can run independently. So if you're not familiar, that's basically what we're dealing with here. Just going to hide my header and toolbar to make this a little bit easier. I'll show the toolbar for a second. So again, if you're not familiar with Jupyter Notebooks, if you are following along in your own browser, be sure that you're running these pieces of code as we go along. So when you have, as you go through, you can either click this run button, which will run a block of code, and then it will move the selection down to the one below. Or if you're like me and you like to use shortcut keys, hold Shift and press Enter, and you'll see that the code runs. So here that 6 just changed to a 7 because that is now the 7th chunk of code we've run. So that's how you know that things are working. So Shift Enter will run code and keep progressing down the notebook. As you can see, I'm just pressing Shift Enter here. Just be sure that you are running these, not missing any cells as we go along. So first thing we're going to do is just import some libraries we'll be using. Then we're going to download a data set we'll be working with. We want to get that out of the way because this can take a while to download. It's a relatively sizable data set. Call it maybe medium, a couple hundred megabytes. And now on to kind of the topic for today. So what we're going to do today is we're going to do a little bit of hands-on. We'll go through some of the actually, code we would write for exploratory analysis, the libraries we would use. But I want to really put it in perspective of thinking about a use case and kind of doing a case study in data science. So really starting with a user-first, problem-first approach, thinking about what we want to deliver and how we can take a broad goal or a vague business problem and find, a meaningful, valuable, quantitative question that we can, ask and hopefully solve as we keep developing our projects. And we're going to think about planning deliveries in New York City. That's going to be our case study for today. And so we'll imagine we're a data scientist or maybe a team of data scientists working for or with a courier service, delivery service in the NYC area. And our goal is going to be to help them make deliveries efficiently. And we're being asked to build some data-driven tools to assist with those operations, to help them make decisions about this very simple question we've been asked: how can we better plan deliveries? We're going to take a focus on turning these broad questions into something very specific. That is oftentimes the role of a data scientist, to help find the sort of sub problems that are going to be tractable and valuable within a broad goal someone wants to do. It's not just a matter of your manager or your client comes to you and says, how can we use this exact data to perform regression to predict this exact label so that we can use it in this exact way. And we'll know we're successful according to this exact metric, right? That's not the degree of familiarity that that our clients, collaborators, managers, necessarily have. And so a lot of that conceptual and kind of direction-based work does fall on the shoulders of data scientists. So that is basically the idea, working with these vague questions, turning general problems, specific subproblems, looking for opportunities within those subproblems. Always trying to focus on who is our user, how can we help them with their goal, and communicate that to them, show them that there's value and that it's worth, buying in or green lighting, I guess pun intended in the case of today's project, further work, more sophisticated analyses. So we're thinking about helping this courier service better plan deliveries, thinking about the types of routes or just the type of setup they might want for planning deliveries throughout the day. This does not mean we are going to be working necessarily towards, I don't know, using machine learning to create some kind of GPS directions app. There are a lot of products on the market for that. Maybe it's not the best use of our time to start from scratch there. On the other hand, we can think about how we can address some of the more courier specific problems for our client, our company here, right? And so it's different from using Apple Maps, Google Maps, City Map, or what have you, because we're not going from point A to point B. We're thinking about how we can handle many deliveries at once. And depending on how our courier service works, maybe we have a fixed number of packages we need for in one day. Perhaps thinking of this like if we are working, just more locally, the way that UPS, FedEx, the Postal Service would work, where we have kind of, collection centers and we're loading things up to deliver the next day. We also could think about a use case where maybe it's more Uber style and people are, more interactively or more dynamically giving us deliveries. And maybe we have a bunch of kind of contractor delivery people. But we're sticking with kind of this more standard idea of, let's say we have delivery trucks. Those trucks have routes. We need to plan how those trucks, sort of work together to service the city. And so that's very different, again, from typical, here's how to get from point A to point B. Here's the fastest route. Because we have to think a little bit more macro level, right? What is this truck or what is this fleet of trucks or delivery vehicles going to do throughout the day? So thinking about what makes a good route, again, not just from an origin to a destination, but throughout the day, there are different ideas that we could explore. Now, for one thing, we probably want closely packed deliveries. It would not make sense to, allocate deliveries to trucks such that they were doing laps around the city between every single delivery, right? There's a reason that the USPS goes door to door, like next to each other, of course. So we need to figure out a way of, ensuring that routes are suitably, like closely packed. Obviously, we want our routes to be fast so that we can cover as much as possible. And we want them to be reliable. If we say we can get something delivered by 5 o'clock, we really want to make sure that we're adhering to that as much as possible. We're going to focus on exploring some ideas about reliable routes for today. The reason we're focusing on reliable, we think about the value of this for our client, our company, and to be sure, like the slogans and kind of focus of many delivery services is that they are reliable. Neither rain nor sleet nor snow, for the USPS. FedEx's slogan is pretty directly about the fact that things get there on time. I forget the exact verbiage, but we want to focus on reliable. In a business use case, if somebody needs it today, or if they need it by 3 o'clock, or if we say we're gonna get it to them between 10 and 2 p.m., we want to be able to stick to that. And so we want to, have routes where we can, be assured that we're not going to have major delays. And so that's what we're going to think about in terms of reliability. If we think that this truck can service this entire area in a given day, can we understand the uncertainty there? Can we understand where we might get major delays and backups that are going to interrupt reliable, dependable service? So that's going to be something that we think about. And that's going to help us to help the company make a decision about maybe the size of an area that a truck should service, the number of packages a truck in that area can carry, and how they can plan, again, efficient deliveries, going back to their broad goal. Now, an end goal here probably is going to get into a real deployed machine learning model, something that can make, really immediately valuable predictions, something that maybe we have like a live deployed dashboard so that, our managers or people in operations can understand performance in real time or in an up-to-date kind of way. Maybe we're getting into actual software that does this, backed with AI, but we can't jump right into that. That's a big time investment. So what we're going to do instead is we're going to get familiar with some available data, some possible external data sources we can bring in, finding questions that data can help us solve, finding some usable signal that will show up, later in further analyses. It's a short demo today, so we are taking a pretty, brief approach. So in addition to, let's say, like internal data we might have at the company, things like delivery schedules, just demand, which we don't have access to for this example, of course. We can think of publicly available data sets and sources for New York City. So a quick survey of those, I'm just going to pull up some of these links. We can access like a sort of, computational representation of the roads in the city. We can look at traffic patterns, and we can also look at occurrences of auto collisions. So these are all going to be found on NYC Open Data, super common data source if you're looking to, do a data science project focused on New York City. They have a wealth of information. So if you are looking for maybe like a topic for a capstone, this is a good place to look for data sets. So we have something like these roads, and we could export these in a way that was computationally useful. That's going to be a little bit complex, so we won't focus for this today, just to get a survey of the data though. We might look at historical data for traffic volume. So looking at different segments of road, and on a particular day at particular times at those different segments, from here to here on this street, going this direction, how many cars passed through that segment of road. While this is historical data, it's something that could still be valuable to us to understand, sort of the variance and unpredictability of particular stretches of road in the city. For something that is updated in real time, or close enough to real time, we can also explore some of the public APIs that New York makes available to us. So this would say something like, for a particular segment of road, the speed at which cars travel, and the time it takes to get from point A to point B on that segment. Again, this is something that would be very valuable in a kind of sophisticated model, but we're just going to leave it as part of our survey for today. And we're going to focus on this data set of motor vehicle collisions. So the idea here is that we're going to have kind of an external, publicly available kind of alternative data set to understand one of the big contributors to, unpredictable traffic patterns, which is when crashes occur, they can block traffic and they can, result in us rerouting or getting stuck in traffic jams. And so we're going to take a look at this data set for today. So looking at the collisions data set, and we have downloaded a CSV of this data in one of these cells above. We're going to go ahead and load that into Pandas. If you are not familiar with Pandas, this is like kind of the big tabular data analysis library in Python. It's super ubiquitous. It's something we use all the time in the fellowship, and really that is just used all over the place in industry. So we're loading up this data frame, and right off the bat, we have a lot of crashes here covering a lot of New York City. And we want to focus just for now as a pilot program on Manhattan. It's very dense. It's where we're going to see a lot of our deliveries. And it just gives us kind of a way of taking a meaningful subset for a proof of concept. So I'm going to say, all right, well, let's filter this down so that we just have stuff in Manhattan. And let's take a look at just the head of this data frame, which is our table. We're just going to look at one row. And it looks like this. So we've got a date and time. We have that it happened in Manhattan. This was the particular zip code, latitude and longitude, and location. So just the same information in 2 columns versus 1. We have the street that it occurred on. We have the cross street. In some cases, we might have this off street. And we're going to have some additional columns. And we're also going to see factors for different vehicles involved, apparently up to 5 vehicles, a unique ID for the collision, vehicle codes for these, apparently up to 5 is the max we're tracking. And we'll notice that we have some missing values in these. So this was a taxi crashing into some other category. And looks like there were no additional vehicles, 2 cars involved. So that's a broad overview. Let's start just processing this data set to make some of our columns a little bit more immediately useful. And we'll focus really quickly first on creating this timestamp column. So we have this crash date and crash time, and we're going to combine those and then turn them into a new data type, a Pandas date time column, which gives us more flexibility and kind of more powerful options in working with times. So I'm going to say this timestamp column, just give me crash date and then a space and then crash time. So that'll just be a string of characters. But then I want to take that and I want to convert that into this date time thing. So now, after we do that, and that'll take a little while because we have a fair amount of data to process, we will end up with that timestamp column. And again, it's a decently large data set, so that'll just take a minute. But we are doing this so that we can do things like if we wanted to resample from these individual times to, let's say, like every 30 minutes or every hour. Those are things that we can do very intuitively and programmatically with Pandas. So just as kind of a little example, if I look at these crash times, again, now I have these timestamps. So I can do things like this, basically. I could say things like, maybe I'm going to take my data frame. I'm going to set the index of my data frame to my timestamp. So basically what that means, now we see timestamp on the left here, which means it's kind of the primary way of accessing rows. And that might let me do things like this. So go to the location, looking at that index. And I could even say something like, I don't need to say it in this format. I could even say something like, I don't know, how about like March 2013? And that would return stuff for March 2013. We're very kind of flexible. Pandas does a lot of kind of legwork for us in handling these dates. Just like a very powerful, honestly, very cool feature that I like to point out. One of many reasons, and certainly not the most powerful one, that working with these date time kind of objects is useful in Pandas. But it's always a cool, quick one to point out. Now, when we think about using these columns to get valuable information, let's check and see, how many missing values we have. If we have a lot of missing values, it might not be that useful. So I can look at whether an individual cell is missing using this isNA method, but I can then take the mean of every column in terms of isNA. And so if we have something like a 0 here, it means that every single crash has a date and time and a borough. And most of them have a zip code. About 3% of them are missing a latitude, and so forth. So let's take a look at which of these have the highest rates of missing values. And we're going to notice off the bat that the 3 big ones are vehicle type and factor for 3 through 5 by kind of a long shot. Also this off-street name, which is telling us something about the location, but maybe it's not immediately clear. Still the case with cross-street and on-street. And we're going to find that for some of these things, like if a vehicle type code and contributing factor vehicle are missing, we're going to take the, for now, kind of the reasonable assumption that that means that there was not, in this case, a second vehicle. Or in these ones, and so it makes sense that so many of them are missing, there wasn't a 3rd, 4th, or 5th vehicle. From there, we've got, kind of casualties and damage, time things occurred, and injuries according to different different categories of possible bystanders. Now, that's kind of an overview. Let's do a little bit more filtering. We filtered down to Manhattan, and now I want to filter to just delivery hours. Again, this analysis is for a courier company, so we don't maybe need to worry too much about deliveries happening at 3 a.m. Let's focus on, again, a quick, reasonable assumption. Maybe we have operating hours of 8 a.m. to 8 p.m. We could easily change that. And I'm writing a function here that makes it very flexible for us to change that. I can specify, actually, what hours I want to start and stop. I would highly recommend, when you are working really in any programming context, to really make a habit of encapsulating code in functions. With Pandas, it's very helpful. With Jupyter Notebooks, it's very helpful because it helps you ensure that things are consistent when you run code. So I'm going to say, OK, let's filter down to 8 a.m. to 8 p.m. And let's take a little histogram and notice that this just takes a little bit of code for us. From our data frame, look at the hour of occurrence, and we can see kind of these patterns at which we observe a lot of collisions. Unsurprisingly, these correspond, looks like kind of between 8 and 9 a.m., morning rush hour, commuting to work. We see a lot between this 14 and 15 is going to be 2 to 3 p.m. It's going to be a big traffic hour, a lot of collisions. And then between 19 and 20 on the 24-hour clock, 7 to 8 p.m. So those are times when we're going to see a lot of collisions. It's like an immediate, strong pattern we can pick out. But we want to drill down a little bit. So ways that we can think about the location-based, kind of location-based information here. Now, I could use location, latitude, longitude, place collisions on a map like in a continuous way. Maybe we could draw little squares on the map and count the collisions in each square. But we want to make use of this street and intersection and cross street and all that stuff, in fact, because that maps, pun intended, I guess, onto the types of decisions that we have to make in planning routes, right? We don't think about turning left or right at a particular set of GPS coordinates. We turn right at intersections, hopefully, rather than going free form all over the place. Now, that might help us understand if there are certain stretches of street that are going to be particularly serious that we need to avoid. And again, we can eventually take this analysis further and think about the uncertainty with certain streets, or maybe what causes, maybe predicting an increase in collisions on certain streets. But to do that, let's create a new column here. So we'll call this an intersection column, and I'm going to say this is the on street / the cross street. And so what this will look like, I'm going to say, all right, so my intersection, let's just take a look here. Head gives me the first 5 rows. Scroll all the way to the right. So the intersection now is the on street where it actually occurred and the nearest cross street. And so we can use this to get little points on our grid of streets, right? And that can tell us kind of at a course level, which intersections have a lot of collisions for one thing. So I'm going to say, okay, well, this little function gives me a little metric here. And I'm going to say, what are my top 20 worst intersections? So count all the collisions, count the number of times each intersection appears. Give me the top 20 of those. And so it looks like, a lot of these areas in like Midtown are looking pretty bad. Certainly looks like, off of 125th Street, it's pretty bad. Makes a lot of sense. Things are looking a little rough in the Lower East Side down here. I guess maybe that's a little bit closer to, we'll call it that. And we can kind of, we can get an understanding of where, in general, there's a lot of collisions. We could, of course, use this information differently, filter by time of day, filter by month, whatever we want to do. But this is just to show that we, can get signal from a feature like this. Some additional feature extraction, sort of like heuristic ways of finding meaningful information in these simple kinds of features. Let's say, well, what if I wanted to get these street numbers from this? So looking at my intersection, I have things like 59th Street, 3rd Avenue. And I might be interested, so 37 and 42 and 125, these tell us like how high or low are we in Manhattan, right? High numbers, we're going uptown. At some point, we hit kind of 0, and we've got a bunch of named streets south of, I guess, what would that be? Houston, I guess. But we can handle that differently, maybe in a future analysis. Here, we're looking at, can we extract out these streets? So I'm using regular expressions for this here, something we cover in the fellowship, helps us find and extract little patterns of text. And I'm saying, okay, well, if I see something ST, let's get those numbers that came before space ST for street. And I can say, cool, let's now create this street number column. Intersection is not defined because I didn't run this cell. That's why you have to run our cells when we run these things. Now, based on that, I can do some filtering. I might be able to say like, okay, well, what about my streets between 1st and 14th Street? Well, I can say, cool, so street number between 1 and 14 inclusive. And I can look in this little area, what are my big places to avoid? 14th Street and 1st Avenue, major intersection, makes sense. Same thing for 3rd Avenue, right around Union Square. A lot of it's 14th Street because that's kind of the main thoroughfare kind of in that kind of downtown boundary area, east to west. And we also might say, okay, well, 14th Street, that's kind of a given. What if I looked at between 1st and 13th, where it's a little bit more interesting maybe. So now I'm saying only go from 1 to 13. Let's look at the top 10 there. And we start getting kind of some additional information. Keeping this rolling, of course, there's, we're kind of building blocks that we can use for further analyses. Also want to talk about a little bit more feature engineering, something kind of more, I think, interesting than this basic extracting a number, which is extracting a particular neighborhood with a particular pattern of street names. So for us, Alphabet City is going to be like a little, arguably just part of the East Village, kind of tiny neighborhood next to it, with street names like Avenue A through Avenue D. So we'll have this little function here that extracts if something is Avenue some letter. And so we can see now that we can extract, like avenue blank. And from there we can say, cool, let's look at just a data frame of that particular area. And now we see that, we're on like St. Mark's and Avenue A, Avenue B and East 3rd Street, right? And I can say, cool, in this particular neighborhood where I might maybe assign a route for a truck or it's part of a route, in there, what do we need to worry about? Looks like Houston, which is one of the main roads, is going to be a lot of it, so that makes sense. But we can also see places where maybe these collisions are occurring on the more residential streets. Looks like nowhere in this neighborhood is actually that bad once we get off of Houston, which is kind of the big street. The Avenue A in St. Mark's, not great. And again, like we might have a lot of like kind of domain level ways of creating these features. Pandas makes it very easy and flexible for us to do this, just using little functions like this, based on our understanding and how we want to map out the city. There's a lot of ways we could do this as well, maybe combining with another data set of like named neighborhoods. But this is just one approach based on the strings here. Saves us the trouble of mapping data sets together. I want to get into a little bit more feature engineering, ways that we can create meaningful interpretations from existing columns. And I want to talk about getting the number of vehicles. So we saw before that we had vehicles, vehicle types 1 through 5. Those could be things like taxi or maybe bus or things like that. Small commercial vehicle with 4 tires, bicycle, passenger vehicle, sport utility vehicle, and so forth. But we notice that this also serves kind of double duty. It also says like how many vehicles. This one is a sport utility vehicle crashing into apparently no other vehicles. And we can use this, we could turn this into a more immediately useful column by just saying, okay, well, how many of these are actually there? So let's turn that into true and false, and let's just add that up, right? True plus false plus false plus false plus false, 1 plus 0 plus 0 plus 0 plus 0. And that's what we're going to look at. I'm going to say get number of vehicles in these columns. Let's look at whether or not they are these na values for not a number, and let's add those up across each row. That would take 1 plus 1 plus 0 plus 0 plus 0 and so forth. And let's basically return a column like that, or actually let's so let's return kind of a little column like that. We can see that by and large most of these are 2 vehicles, which is a decent sanity check. Very few with 5, very, very few with 0, which seems appropriate. That's probably kind of errors in our data, but we're not immediately sure. Doesn't seem like it's constituting a lot of the data though, so it's probably not a big deal. And we have some, next occurrences with 1 vehicle, all of which kind of makes sense. We can take that, we can join it onto our original data. So Pandas makes it very easy for us to merge these separate sources by finding kind of like appropriate indices for those joins. So now I also have this number of vehicles kind of thing I can use. And maybe something I want to do from there is say, okay, well, if I look at my different intersections, before I said what was the count of accidents at each intersection, but also maybe how many vehicles are in those. And I might be interested in, for these intersections, maybe with really high counts, do any of them have like particularly different patterns in the number of vehicles? Or maybe, since I'm sorting here to look at high counts, maybe I could also say, okay, well, let's go by the mean number of vehicles. And it looks like, okay, well, for a lot of these, the count is 1, and that kind of artificially inflates the mean. So that's maybe not that interesting. But, we could also certainly take an approach where we, filtered out. Maybe I only care about ones where the count is over 50 or over, 30. Again, this is working our way towards finding meaningful interpretations of this alternative data set. We've been trying to focus this on, how can we turn this data into, helping this courier company find like reliable routes so that we know that, let's say, like this truck can service this area. So we've been setting up kind of a data source through some initial kind of feature extraction to understand like, what can we say about the occurrences of crashes in these areas? We'll use that in the future, in addition to traffic data, like traffic volume or the time between points. And of course, we would want to merge that onto a primary data set, which hypothetically we would have, which is like deliveries being requested, right? So maybe we don't want to go by like this rectangle of streets, but if we cluster maybe our deliveries, where we say each truck can handle 100 deliveries per day or whatever it is, bringing in this additional information to further check our understanding of the uncertainty of travel time for different routes. So we've seen a fair amount of information today, tried to take this case study approach, think about the types of decisions we can help people make. We've done a very quick, I know, but quick demo of some of the tools and libraries that we use a lot in the fellowship. And we've shown how we can turn that stuff into kind of new interpretations that are more immediately useful. We haven't done any crazy machine learning, but we've seen how we can kind of take a little domain knowledge and find like meaningful answers kind of at the first step. Last thing I will say, another idea that we might look at, and we certainly do look at in the fellowship, is, okay, well, maybe I do want to sort by mean, but when things have a very, very low count, maybe I shouldn't give too much credence to that. So we can look at ways of sort of modifying that mean based on the count, kind of doing a type of smoothing based on our confidence or level of evidence in the data. That's a topic that we'll save for the, certainly for a lecture in the fellowship. But the basic idea is that we would be doing a type of Bayesian smoothing. Not a conversation for now, however. From here, if we think about like how we could take these analyses and kind of make them more reproducible, doing things like packaging up our libraries with virtual environments, which I have done with Conda, hosting these online so that other people can use them. We've done that with Binder here so that we can access it live and interactive in the browser, making sure that we download our data in kind of reproducible ways. You can see how I've done that at the top of this notebook, and thinking about future next steps with the problem, how can we group deliveries, could heuristic rules like neighborhoods or zip codes, or maybe clustering, like where are these like kind of dense clusters of deliveries coming from? So this gets into some unsupervised learning. And then also thinking about kind of supervised predictive approaches we can take. How can I predict a best route, or how can I predict whether or not a route can get through a number of deliveries in a certain time period? Or how can I predict whether or not a route will be delayed? And then we can think about, for that model, bringing in those other data sets once again. So this is a quick demo. There's a million directions we could take this in, but I hope this has been valuable in introducing some of the tools and also, hopefully elucidating sort of the first steps and, where do we start to find like valuable information in our work as we, work with clients or end users. That's going to wrap up the kind of main part of today's demo. I'm going to turn things back over to Sierra. Thanks, everybody.
Thanks, Michael. Just share my screen. Okay, so a little more about our fellowship program. A big component of our program that we really pride ourselves in is helping our students not only grasp data science, but also getting placed in that field. So you'll see from the screen here that 97% of our students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers, and we're very proud and have worked hard for them. Let's see, so where are our graduates working and what are they doing now? Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And then some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and the industry, but these are just some that we've placed in the past. Here's a short list of some of our hiring partners. You're also able to email us at admissions@thedataincubator.com for a more detailed list of our hiring partners. Again, we will include our email in the chat, so that just send us an email and let us know what your questions are there. So some of you have asked about our financial options and if we offer assistance, and the answer is yes, we do. Especially during times like these, it's hard because people may have extra time to participate in our program, but limited cash flow. So we want to help you with that. We've partnered with Leaf to provide an income sharing agreement. It's great. You can participate in our program with just the deposit down, and you won't be required to make any payments until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Skills Fund, and there's some links on our site on this slide here to the different offerings that we have. We can also send those to you via email if you'd like to review them in more detail. So where are we right now? Well, we run 4 full-time cohorts a year, and we are actually starting our spring cohort early April, but our application will open for our summer cohort on March 22nd. Our summer cohorts will run from June 28th to August 20th for our full-time program, and then June 28th through November 12th for our part-time program. As I mentioned earlier, the full-time cohort is 8 weeks long and the part-time cohort is 20 weeks long. Some specifics about the application: we ask that you submit it by April 16th. You'll have 72 hours to complete the challenge from the time that you open it, and the challenge deadline is April 18th. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We're unable to reopen the application or challenge after those deadlines. So these dates that I mentioned are for our early admissions. We also do regular admissions after our early admissions cycle. The difference there is we really evaluate applicants on a first come, first served basis. So if you want a better chance of getting a fellow spot or knowing earlier if you've been accepted into the program to secure financing, I absolutely recommend applying for early admissions. We also offer a priority enrollment package that includes a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for direct payment. If you're interested in applying to our program, which I hope you are, you can go to thedataincubator.com/apply to submit your application. And if you have questions about your specific situation, this presentation, or going through our application process, please reach out to us at admissions@thedataincubator.com, and we'd be very happy to answer your questions. So with that, I will open it up to the Q&A. If you haven't posted any questions in there, now is the time to do so, and we'll be going through and answering those. So the first ones that I see, I think are more directed to Michael. This one says, when one encounters missing values that are important to answer a particular question in the data set, what does one do, and what is the best way to deal with missing data?
All right, sure. This is a great question, and it's one that I have to start with everybody's kind of least favorite answer, which is that ultimately it kind of depends. This is dependent, of course, on the data and the problem, but one thing that I might advise starting with is, when we have missing data, it's not always about how can we fill this in, how can we like impute or estimate reasonable values. Often there's really good reasons to do that. But what I want to suggest first is when we do have that missing data, can we correlate those missing values, like let's say, frequency of them occurring, with other patterns in the data? Do we have missing data at random, in which case maybe we can just drop this information? Or maybe is there some process that's contributing to or associated with missing data? For instance, in our context here, maybe are certain features missing at different times of day more often, or in different areas more often? If so, then just getting rid of rows in our table, so to speak, could be problematic for us.
Another question here is, where can we see more exercises or problems to try and understand different options?
This is kind of a broad question, so I don't know if I have like any single resource, but I will say that, you know, searching in particular for like data science case study questions, data science case study examples can be a really valuable starting point. So not just technical tutorials, but I think that keyword case study can be super helpful in relating it to, you know, real industry projects.
Another question here, where can I go to learn how to set up an environment like the one you just used for the demo?
That's a great question. So in this demo, so I'm deploying on Binder, but making use of something called Conda for keeping track, making sure we have all of the right software. So to do this on your own machine, you need a Python distribution and you need that Conda library. So I'm going to put a link in the chat, kind of a good starting point for getting a Python distribution if you don't already have one, which is this Anaconda distribution. So this will let you download Python. It also comes with a lot of the big like data science libraries. So you can use them out of the box. And it gives you software for creating and using those environments as well. The documentation is going to have a lot of information about using their kind of point and click graphical interface tool for doing all this. And there also is a command line interface, and they have good tutorials and documentation on that as well.
Another question here is, where can one learn the mathematics specifically related to what is given in the challenges?
I will say that the challenges, we have one that is based on working with a data set. Typically, you know, I see people do this in, you know, using different tools and languages, but oftentimes Pandas is a good way to go, Python and Pandas. A lot of people use R and just kind of R data frames as well, also a good way to go. But I would say that, you know, looking into getting started with Pandas official documentation, just using the library, using Jupyter Notebooks, and, you know, maybe just searching for kind of external use cases and tutorials with Pandas is a great way to do the to prepare for the data side of the challenge. The other side of the challenge involves a lot more like algorithmic thinking, sometimes some probability. And for that, I don't know that I have a number one resource I would point to, but I would say that studying kind of like classic computations, you know, computer science problems, studying kind of like ideas in probability are often very helpful.
Well, I am not seeing any other questions in the Q&A or in the chat, but if you have some questions that you'd like to ask offline, you're always welcome to email us at admissions@thedataincubator.com. We also put a link to our website in the chat, and all registered attendees will receive an email with a link to the session. It's been recorded, so you can review it again at your leisure. And I'd just like to thank everyone for attending today, and hopefully we'll see your application soon for our summer cohort. Thanks so much, everyone. Bye.